Hello guys, welcome to the mechanic class. I appreciate you so much for being part of the class. I promise it's going to be so impactful. We're going to learn together. This is a journey. We are starting this journey today, and I believe that this journey will lead a lot of success in our lives. Please don't hesitate to be part of the mechanics journey. Thank you. Today we are looking at physics 102 as we had on our timetable today. So what we are going to look at is electrostatics. What do we mean by electrostatic? What is electro? First of all, let's look at the word electro. What do we mean by the word electro? I believe some persons will be giving answers like electric charge, electrons, all of that are correct. Electron, electric charge, electric current, all of that. So now what of static? Static, at rest, yes, stationary, not moving, all of that. So now when we join the two answers together, when we join the two words together, we will have electrostatic. From there, we will understand clearly what electrostatic means. So, who can give us a definition of electrostatic? Okay. So now, let's take the definition of electrostatic. Let's say electrostatic is a branch of physics that deals with electric charge at rest and its fields potentials. Okay, it deals with the electric field, electric potential. It deals with all that. So do you understand? So now we are looking at electric field. We'll go to electric field. Now what is electric field? What is electric field? Do you understand? Everything has its field. We can have gravitational field. We have magnetic field. We have electric field. We have magical field. And when you enter into the fields, you experience the forces. If you enter inside magical field, you experience magical forces. If you enter in the Shiran, where Baba is going to misbehave, you carry force and come back. If you enter electric field, touch a naked wire, and a force will be experienced. Gravity, all those things are fields. So now, field itself is a region around electric charge. Okay, electric field is a region around electric charge. But the electric, let's step down. The definition is the region around an electric charge. We are electron experience the force. So for electric field, that is the definition. It is the region, the area around electric charge. So now let's look into electric field strength or electric field intensity. So now electric field intensity, that is where I said it is the strength. It is the strength that is experienced per unit positive test charged, placed in an electric field, placed in the region of electric charge. Do you understand? Electric field intensity, we're talking about the force experience, right? So now the formula will be force over charge, where F is our force, or let's say electric force. Electric force. Q is our charge, or our electric charge. What is it? Coulomb's law of electrostatic says something. Coulomb's law of electrostatics states that electrostatic, as charged is directly proportional to the product of the charges and inversely proportional to the distance between them, the distance that separates them. Okay? We have force of repulsion, we have force of attraction. So now let's do something really. This is our positive charge and this is our negative charge. The fundamental law of electrostatics say that like charges, like if we have positive and positive, they will repel, and negative will repel, but negative and positive will attract. So now this is negative and positive. The like charges will repel, unlike will attract. So now we have positive charge and negative charge. When we experience a force of attraction, we are going to experience a force of attraction. All the electric lines of force will be going towards the direction of each other. They will be attracted, they will be going towards the unlike charges. So there is a force that is going on here. The force that separates them. There is a force going on here, and this is the force that we're talking about. It can either be force of attraction. This is the force of attraction. The force of attraction and between unlike charges. And the force of repulsion. The force of repulsion, you see that if it's like charges, you experience a force of repulsion. And they will be going separately from each other. They will not attract, they will be repelling. Okay, so now the force studying this is the force of repulsion or repulsion, and you want to call it the force of repulsion. That's why Coulomb's law says that the force between the two charges is directly proportional to the product of the charges and inversely proportional to the distance that separates them. It can either be this distance, this is the distance we are talking about. This is the distance. The distance between here and here represents it to be 2 r. This is the distance. This is the distance. The distance between here and here, that's the distance that separates the two charges from each other. The distance that separates this positive charge and the negative charge is the distance we are talking about. So now, let's explain this. To verify what Coulomb's law says, this is Coulomb's law. It says that the force between two charges, is directly proportional to the product of the charges, which is Q1 and Q2, and inversely proportional to the square of the distance between the charges. That is Coulomb's law. So now, understanding this principle, we can apply this to our electric field intensity. You see that we have electric force here, our electric force here and a charge. So what are we going to do now? Our electric force intensity is equal to F over Q, where our F is equal to K. So this is a constant K. This is a constant K. Q1, Q2 over R squared. If they give you the product, the two charges, you use this formula. What if they give you a charge at a point due to a point, that means they give you a single charge. Which formula are you going to use from this one? Because you see here, we have two charges and a distance. So what if they give you a single charge? That means you should you should solve at a point or due to a point. What are you going to do? That's what we are going to do now. This way we derive the formula. So our electric force here is F over Q, electric force over this. So now, we're using the formula that Coles gave us. We're going to substitute it. This is our F. That's our F. Our F is equal to the same is directly proportional to. Is directly proportional to. So if we are removing a proportionality sign, you have to introduce a constant. That's the constant. And so now we have F there is Q1, Q2 divided by Q. Do you understand? Because this is it, and we are having a division sign, it's going to divide by another charge, which is this Q. So how are we going to solve from here? We have Q1, Q2 over R squared. It's the same thing as this, right? The whole of this is the same as this one, right? So what are we going to do from here? We take the reciprocal of this, so that the sign here will change to multiplication sign. Okay? So now we are having K1 plus R squared times 1 over what? Q. From here we are using that this Q will cancel. One Q from here will cancel this Q, and we are going to have KQ. That's what has KQ over R squared. So for example, if they give you a question due to a point, the electric field density due to a point, you are going to use this formula, where K is a constant, and the constant K is given by 9.0 times 10 raised to the power of 9.